Hi friends. Okay, this is like a review of basic inequalities. This is meant for pre-calc students or higher. So I'm going to go through this very quickly because I assume that you know this. It's just a quick refresher. So the inequalities. So we've got less than, which I always think of looks like an L, less than or equal to, greater than, and then greater than or equal to. And with these, we have these properties. So if you have A, B, and C be real numbers, so the things to remember here are, so if you have A is less than B, A plus B is less than B plus C, i.e. you can just add a number to both sides and it will maintain the inequality. Now, where this gets tricky, and the reason I'm bringing up these properties is, so let's say you have A is less than B, and then you have C is greater than 0, meaning C is some positive number. Then if you multiply both sides by C, the inequality remains unchanged. But the third one is the one that really matters. If A is less than B and C is less than 0, i.e. if it's a negative number, then notice what happens. AC now is greater than BC. So the direction of the inequality flips. So that's the one that sometimes people forget that I just wanted to take a second to review. And this counts for if you're multiplying or if you're dividing. So you just have to kind of keep that in mind. So with that in mind, I'm just going to jump into some examples just to refresh your memory. So I'm going to ask you to put your final answer in interval notation. Now, interval notation I cover in another video because if you forgot it, it's a little bit of work to re-explain. It's not a huge deal if you forgot it. I will drop a link in the description to the interval notation video and it will just remind you of how everything works. So not a big deal. It's just I'm trying to keep this particular video short. And maybe if you see me use it, it'll jog your memory. Okay, so I've got negative 2x plus 8 is less than 10. So I want to solve for x. And I can really just like think back to how I might, work with a equation, kind of using some of the same ideas, right? So I subtract the 8 and then I divide both sides by negative 2. However, I know you're saying, oh, we're dividing by a negative. Therefore, what happens to the inequality? It flips, right? Okay, so x is greater than negative 1 is the solution, but we have to represent it in interval notation. Now, the easiest way to represent an interval notation in my experience, especially if you forgot, is to first graph this on a number line. So here's negative 1, here's 0, here's negative 2. So if I start here at negative 1, so which way is going to be the greater than direction? Is this greater than or is this greater than? This side is greater than. And then what symbol do I put at negative 1? You have two options. You can use, since it's a greater than, you can use an open dot or you can use a round parenthesis. Doesn't matter, they literally mean the same thing. I'm probably partial to using the parenthesis, so that's what I like to use because now when I want to write interval notation, it actually just makes it easier. So with interval notation, so really what you're trying to represent is what did you shade on the number line? And so we started at negative 1, but the thing with interval notation is, so if negative 1 is not meant to be included, which it's not, right? X has to be greater than negative 1. That means negative 1 is not included. So when the number's not included, you always use a parenthesis. And so we read this from like a book, so we read it like from left to right. So I'm nothing, nothing, nothing. Oh, I start here at negative 1, so negative 1 is not included. And then I continue on this direction. So going this direction forever, this is the positive infinity direction. So this goes to infinity in interval notation. Now infinity is not a number, so infinity always gets a round bracket. So hopefully that reminder of interval notation helps you. If you feel like you're totally lost, just check out my video on interval notation. I think it'll be worthwhile if you still don't remember it. Okay, so next let's move on to a harder problem. Harder in that it's just got a little bit more algebraic heavy lifting, if you will. Okay, so I've got negative 1/3 x plus 3 plus 1/3 x plus 2/5 x is less than or equal to 1/10. All right, so these fractions are an abomination. I am not dealing with them. I want to get rid of all of them. So instead what I'm going to do is I'm going to use the old LCD trick. So I've got 3, I've got 5, I've got 10. So of these denominators, what would my least common denominator be? It would be 30. Right, so 10 is 2 times 5, this is 5, this is 3. So you've got to have the factors of 2, 5, and 3 in your LCD, so that would be your LCD. And so then what I'm going to do is I'm going to multiply each fractional pair by 30. Now the thing that everybody forgets when they're using this trick is that this right here, this 1/3 times x plus 3, this is considered, I always just call it its own thing. It's its own term is the technical term, but I just say it's like its own thing. So I would multiply 30 by this, and this. So let me just show you what that looks like all set up. Okay, so this is the old LCD trick. And so notice that I've now gone through and each part of that inequality I've multiplied by 30. And the reason that I did this is now I can cancel out my denominators. So the way that works is that I think to myself, okay, so 3 and 30. So 3 goes into 30 how many times? 10 times. So I can cancel this out and write 10 here. And then, how do I simplify this? So now I've got 10 times -1. Don't worry about the parentheses. The parentheses are just coming along for the ride. Just worry about what's in front of the parentheses right now. So that just becomes -10 times x plus 3. We'll sort out the rest in a moment. Okay, so let's keep going. So now I've got this little pair here, right? So I've got 30 times 1/3. Same thing, right? So 3 goes into 30 10 times. So I can simplify this to 10 times 1x. 10 times 1x. That will just leave me, of course, with 10x. Then, this little pair here, 5 goes into 30 how many times? 5 goes into 30 6 times. So now I've got 6 times 2x. And by the way, just do you see how like I'm being a little bit intentional on how I'm writing this? So I'm trying to give myself enough space so that I can see a meaningful calculation. So this is a lot to write down. And you really want to stay neat with this because otherwise you could get very easily lost in your handwriting. I don't know if that's ever happened to you, but I do see that happen to a lot of students. So 6 times 2x, so that becomes 12x plus 12x, and then less than or equal to, and then finally, how many times does 10 go into 30? It goes in 3 times. So then I'm left with really, this is 1 times 3, so that's just 3. All right, and so now, do you see like how much easier this is? This is nice. I'll deal with this. I am not dealing with this noise up here. Wow, no thank you. Okay, so let's go ahead and distribute. So I've got -10x minus 30 plus 10x plus 12x is less than or equal to 3. So now I see here that the 10x's actually drop out. And so now, let's see, I've got -30, plus 12x is less than or equal to 3. Oh, and I dropped the x, my bad. And I'm running out of space here, so let me clear some room. Okay, that's much better. So now I can add the 30 to each side. So I've got now 12x is less than or equal to 33, right? And okay, so now I can just divide both sides by 12. That's a positive number. So this is just going to be 33 divided by 12. Let's see, 3 goes into the top and the bottom, right? So I could simplify that to 11, and then let's see, 12 divided by 3 is 4, so that would be 11 over 4. Okay, so we're not done, right? So we've got to put this in interval notation. So number line, and here's 11/4. And I always like to have my answer with the x on the left. I just want to point that out. That's just an aesthetic thing that I like. Okay, so now, which direction is the less than direction? It would be on this side here, right? So over here, Okay, and then as far as, so 11 over 4 is included in this case, right? Because it's less than or equal to, so the or equal to would mean that 11 over 4 is included. So your options are, you can use a square bracket to represent that or a closed dot. It does not matter which one that you choose. It is totally a preference thing. I like using brackets. And then to do the interval notation, so now in this case, this direction here, this is the negative infinity direction. So remember, you read this like a book from left to right. So I start here. This is starting at negative infinity. Infinity is not a number, therefore it can never be included, so it always gets a round bracket. So I start at negative infinity, and then I go do 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 do. Do you like my songs? Do 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 do. And then we're at 11 over 4. 11 over 4. 11 over 4 is included. Since it is included, it gets a square bracket. So boom, there you go. Okay, so now we're going to move on to the 3-part inequality. A lot of people just forget like how this works. And it's really no different than a regular inequality. So to solve this, what you want to do is just think about for a second, pretend this is the inequality. How would you solve for x in this case? So you subtract 1, right? And so instead of subtracting 1 from just one side, so you subtract 1 here and here, but you subtract it from all 3 sides. That's basically it. And so then this becomes negative 6 is less than or equal to 2x, which is less than 12. Then I need to divide by 2, so I divide all sides by 2. I'm dividing by positive 2, so the signs don't flip. So I'm left with this. Okay, so how do we write this in interval notation? So the thing to remember with this is really what this is getting at in interval notation, or what this is trying to say in inequalities, is that x is between -3 and -6. And so if you think of it like that, the inequality like that, then the number line becomes pretty clear. So it's all the values between -3 and -6. Now, does -3 get a square bracket or a round bracket? It gets a square bracket or a closed dot. Now, I'm just going to tell you that in most of my videos, I usually use just the square brackets. So if you use the closed dot, you're just going to want to remember that. And then what about 6? Does 6 get a square or a round bracket? Well, 6 is not included, therefore it gets a round bracket or an open dot, whichever you prefer. And now the interval notation is actually pretty simple, and that's, remember, we go from left to right like a book. Nothing, nothing, nothing. Starts at -3. -3 is included, so it gets a square bracket, and then we go all the way to 6. 6 is not included, so it gets a round bracket, and boom, there you go. All right, so since this is in the spirit of review, I suggest that you pause the video here and you just try to finish this one on your own. Hit play when you think you've got it. Math is not a spectator sport, so highly recommend that you give this a try. Okay, so what I need to do, this is another 3-part inequality, so I'm going to add 3 to all sides, so I get 5 is less than or equal to -6x, which is less than or equal to, oops, just less than 12, my bad. Divide all sides by -6. Now, notice we're dividing by a negative number, so what happens? All of your inequalities flip. Now, I don't like I like having a certain direction with my inequalities. So this is fine that this is what I came up for with the answer, but I like the inequalities to all go this direction. So I'm actually going to flip the order here, because this helps me to just think through then how to do my number line. So you don't have to do this, but I think this just makes it easier to figure out what to do next. So then here's -2, here's -5/6. Shade everything in between. So -2 will get a round bracket, and -5/6 will get a square bracket, and then my interval notation looks like this. And so that's just your really quick review of just your basic inequalities. If you are looking for more, you can look in the description of this video. This is meant to be a review for pre-calc students. However, you know, not everybody needs the same level of review. So if you watch this and you're saying, oh no, I need like way more, I forgot all of this, no problem. You know, I'll meet you where you're at. So I will drop some links in the description if you are looking for longer, fuller, more complete lessons. And otherwise, if you found this helpful, please consider liking the video or leaving a comment, sharing with your friends, or subscribing. And otherwise, I will talk to you guys in the next video.